Okay, so let's talk about the order of operations. The order of operations is used so that we all get the same answer when we're performing multiple operations within one expression or within one problem. Okay, so again, recall the order of operations is a set of rules used to determine the sequence in which operations are performed in a mathematical expression. This ensures that everyone gets the same result when solving, or not solving, but simplifying expressions. Okay. So the steps to the order of operations is to perform all operations within grouping symbols. So grouping symbols can be parentheses, they could be brackets and braces. You could also see absolute value. We've done a couple of examples in previous videos where we treated absolute value almost as if it was grouping symbols. You could also see a square root. If underneath the square root you had addition or subtraction or multiplication or division, it could also be considered a grouping symbol. We also want to work from the inside out. So if we have nested grouping symbols, start on the inside, simplify your way out. Okay? Next up, you could evaluate any expressions with exponents. You could also put square roots here if you prefer. You want to multiply or divide from left to right. And then finally, the last step is add or subtract from left to right. So a lot of people remember PEMDAS, and I am writing it kind of silly like this, so PEMDAS. The P stands for parentheses, but just know it's all grouping symbols. The E stands for exponents. The MD, that stands for multiplication and division. And just remember, we do multiplication and division in the same step. We just work from left to right. So whatever comes first from left to right, take care of that first. And also addition and subtraction, we do those together in the same step, just working from left to right. If you're not familiar with PEMDAS, you might remember please excuse my dear Aunt Sally. So it's just another way to remember the order of operations. So parentheses, exponents, multiplication, division, again, left to right, same step. Addition and subtraction, same step, left to right. Okay, so that's the order of operations. Now we need to practice. Okay, so let's look at example 2. It says perform the order of operations to simplify each expression. Okay, so part A, we do have a situation here where we have nested grouping symbols. So notice for example A, we have brackets, and then inside those brackets, we have braces or parentheses. We want to take care of this first, then deal with a larger set of brackets second. Okay, so first thing I'm going to do is go inside those parentheses that are inside those brackets, and I'm going to take care of -3 plus 5. So we can do a little side work. We have -3 plus 5. We're adding two numbers. Now, this is adding, so you've got to always understand the difference between adding and subtracting compared to multiplication and division. When you're adding and subtracting, it comes down to same sign versus different signs. If you're adding the same sign, you add and keep the sign. If you're subtracting or adding different signs, rather, you subtract and then keep the larger sign. So I'm dealing with addition of two numbers with different signs. That means I really subtract, and we're technically subtracting absolute values. So I want to take 5 minus 3, which is 2, but then I have to ask myself, is this 2 going to be positive or is this 2 going to be negative? So right here, I have 3 negatives, but I have 5 positives. That means I have more positive than negative. So this 2 is going to stay positive. So what I do now is I'm going to rewrite this entire problem, but where I see that parentheses with the -3 plus 5, I'm just going to replace it with a +2. So I have -4 brackets, and then inside I have -6 plus 5 times parentheses where I had -3 plus 5. That's just going to be 2. End your brackets, and then we have negative or -7. So inside the brackets, we have two things happening. We have addition and we have multiplication. Okay, so what I'm dealing with is -6 plus 5 times 2. Well, I need to do the order of operations on this miniature expression first. Okay, so when we're inside that set of brackets, we have the addition and the multiplication. We need to do the multiplication first. So I have +5 times 2. We know that +5 times +2 is just 10. So I'm going to rewrite this whole expression. But where I see the 5 times the 2, I'm going to write it as +10 because it's positive. And then don't forget that 7 that you're subtracting on the outside. So now inside parentheses or inside the grouping symbols, the brackets, we have -6 plus 10. Okay, Well, -6 plus 10, again, we're adding two numbers that have different signs. So when you're adding numbers with different signs, you subtract their absolute values. So I want to take 6, or I want to take 10 and subtract 6, which is 4. But again, we always have to double check our signs. So I have 6 negatives, but I have 10 positives. Since I have more positives than negatives, this 4 is going to stay positive. So I'm going to rewrite this whole expression, but instead of -6 plus 10, I'm going to write it as +4. Now, these brackets are just indicating multiplication at this point. There's no more grouping symbol left. It's just keeping that 4 separate from the -4. So we know it's not 44, it's -4 times 4. And then I've got my -7. So according to the order of operations, I would do my multiplication first, then my subtraction. So -4 times 4, I'm multiplying. So remember, when you're multiplying and dividing, it comes down to same sign versus different sign as well. But when you're multiplying the same sign, it's positive. When you're multiplying different signs, it's going to be negative. So we have 4 times 4, which is 16. But because I had different signs here on these two factors, I want to keep this -16. And then I want to subtract 7. So off to the side, I'm going to do the subtraction. This has been several videos ago, but remember, subtraction can always be rewritten as addition. We know the rules for adding, okay? So I want to convert this to addition by keeping the first number the same and then adding the opposite of the second number. Since I'm subtracting +7, I want to add -7. So now I'm adding two numbers that have the same sign, which means I add and just keep the sign. So I'm going to add these two absolute values and then just keep it negative. So 16 plus 7 is going to be what? 23? And it will end up being -23. So my final answer is, whoops, I forgot my negative. My final answer is -23. Okay, be really careful of the order of operation. No individual step is particularly difficult. It's just keeping organized and keeping track of all your steps. So every time you do a step, rewrite the entire problem. These problems should take up a good bit of space on paper. Okay, so this is not the space that you want to save paper on. Okay, all right, part B, we have 24 divided by 8 plus 4 times 2 minus 6. So looking at the order of operations, remember PEMDAS. We don't have any parentheses or other grouping symbols, so we don't have to do step 1. We don't have any exponents. We don't have to do step 2. We do have multiplication and division, okay? And the deal with multiplication and division is you do whatever shows up first from left to right, okay? So I notice here I've got division and then I have multiplication. Because division shows up first, I'm going to do it first and then I'm going to do the multiplication second. Okay, so 24 divided by 8. I really need to ask myself, what do I multiply 8 by to get 24? Well, I would have to multiply 8 by 3 to get 24. Therefore, 24 divided by 8 is 3. All right, so I'm going to replace the 24 divided by 8 with a 3, and then I'm just going to rewrite the whole problem again. Now I'm to the point where I need to go ahead and do that second step, which is the multiplication. Well, 4 times 2 is just 8. So I get 3 plus 8 minus 6. And now we're at the point where we're just doing the addition and subtraction. So again, we just go left to right. So left to right, I have addition first. So I have 3 plus 8, which is 11. Drop down your minus 6. And then finally, 11 minus 6 is 5. And that's it. So I say that's it, like this is a piece of cake. They definitely take a little bit of work, okay? They take a lot of organization, and I find that most of the time the issues with the order of operations is just a lack of organization. Be neat and organized, show your steps, watch your signs, and then just make sure you follow the order of operations as well. So let's look at part C. So part C already, most of us are going, oh man, because it's got fractions in it. Fractions are not necessarily difficult, but they are a lot of extra work, okay? So let's go through the order of operations. Remember PEMDAS. We definitely have exponents. We definitely have grouping symbols. We definitely have multiplication, and we for sure have subtraction, okay? So we need to start with the grouping symbols. This right here is what we're going to do first, okay? So I'm going to come off to the side. I've got 7/10 minus 8/15. So we need to find an LCD, okay? And you can do a lot of different things to find the LCD. You can start with a smaller factor or the larger factor. Let's start with the larger factor, 15. Does 10 divide into 15 evenly? No. So that means 15 is not the LCD because 10 doesn't divide into it evenly. So now we want to start looking at multiples of 15. So a multiple of 15 would be 15 times 2, which is 30. So we know that 15 goes into 30 two times, but does 10 also go into 30? Sure does. So that makes the LCD here 30. That is just the smallest number that 15 and 10 both divide into evenly. So now we have to come up with equivalent forms of these two fractions. And we do that by rewriting them using the LCD. So ask yourself, for 10, what would I multiply 10 by to get the LCD of 30? Well, you would just multiply it by 3. So I'm going to multiply top and bottom of the first fraction by 3. That will give me an equivalent form where 30 is the denominator. Looking at the second fraction, I have 15 as the denominator. What would I multiply 15 by to get 30? I would multiply it by 2. So we're going to multiply top and bottom of the second fraction by 2. And that's going to give me 21 thirtieths minus 16 thirtieths. And then all we do is we add or subtract the numerators and we keep the common denominator. So 21 minus 16 is 5 over 30. And then 5 over 30 reduces. 5 divided by 5 is 1. 30 divided by 5 is 6. So this really just becomes 1/6. So I'm going to rewrite the whole problem, replacing this underlined portion with just 1/6. So I have negative 1/2 squared minus 1/6 squared times negative 18. Okay? So it takes a little bit of work for sure. There's lots of things going on here, but be neat and organized. Okay, so we've taken care of grouping symbols. We now need to look at exponents, and we have two situations that have exponents. So first of all, we have negative 1/2 squared. Well, in the previous video, we talked about negative bases with exponents. So if you have a negative base in parentheses, that negative is part of the base. So the negative is part of that repeated factor. And when you have the negative in parentheses, the exponent determines if this is going to be positive or negative. If the exponent is even, this is positive. If the exponent is odd, this is negative. Our exponent is even, our negative is in parentheses, this is going to be positive. And then all you have to do is square each part of the fraction. So this is going to be 1 squared over 2 squared, which is just 1/4. So this right here gets replaced with positive 1/4. Okay? Now let's look at 1/6 squared. Notice the negative is not inside the parentheses. So that minus sign is truly just subtraction. It is not part of the exponent. So here I can just take my 1 and square it, my 6 and square it, and then subtract that result. So I'm going to subtract 1 over 36. And don't forget, we're multiplying by negative 18. Okay? So we've taken care of the grouping symbols, we've taken care of the exponents. Now we need to look to see if we have any multiplication or division. And we do have one multiplication. It is right here. Okay, so I'm going to go off to the side, do a little side work. I have 1 over 36 times negative 18. All right, and because there's a minus in front of the 1 over 36, I'm going to treat it like it's a negative. Okay, I'm going to put my negative 18 over 1. And I want to simplify this if I can. So you may not see it, but 36 can be written as 2 times 18. So these 18s really cancel each other. 18 divided by 18 is just a 1, so they cancel, leaving a little footprint of a 1 behind. So when I multiply this out, my numerator is negative 1 times negative 1, which is positive 1. My denominator is 2 times 1, which is 2. So this underlined portion really just becomes positive 1/2. And remember, we took this negative and we put it with that 1 over 36. It's no longer negative. This whole thing became positive. So now I have 1/4 plus 1/2. Okay? And because we're in the final step, we don't have to go and do any weird side work. We can just do it in the body of the problem here. We need an LCD. Okay, so let's look at the larger of the two denominators, 4. Does the other denominator of 2 divide into 4? Yes, it does. So that means 4 is the LCD because it's the smallest number 4 and 2 divide into. So I need to rewrite 1/2. So what would I multiply 2 by to get the LCD? I'd multiply it by 2. If I multiply a denominator by 2, I have to do the same thing to the numerator. So this tells me I really have 1/4 plus 2/4, or finally, after a whole lot of work, we get this to simplify down to just 3/4. Okay, so use extreme caution when you have the negatives and the positives. Use caution with those exponents because you could have negative bases. Use caution with the fractions. Fractions are always a little extra work. A problem like this doesn't look that hard on the surface, but it's got a lot of steps going on behind the scenes. Okay, now part D, we have something that looks like a fraction. So when I have something that looks like a fraction, I treat it as two separate problems. I look at just the top or the numerator. And then I look at just the bottom or the denominator. Okay, so let's look at just the top for now. We're going to follow the order of operations for just the numerator. So we have, again, PEMDAS. So for the numerator, I definitely have parentheses. So I need to take care of what's inside parentheses. And I have 4 minus 9. So if you need to, 4 minus 9 can be rewritten as addition. We take 4, and instead of subtracting positive 9, we add negative 9. So when you're adding two numbers that have different signs, you subtract their absolute values. So this becomes 5. And then we ask ourselves, did I have more positive or did I have more negative? I have 4 positives, but I have 9 negatives. So that makes this negative 5. So I get 5, and then those parentheses, that's just going to get replaced with negative 5, and then plus 10 times 3. I don't have any exponents, so I can ignore that step. I do have multiplication. I have multiplication here and here. So we have two different products that we need to find. First, we have 5 times negative 5. So when you're multiplying, it comes down to same sign versus different signs. If you have the same sign, your product is positive. If you have different signs like we have here, your product is negative. So we want negative 5 times 5, which is negative 25, plus 10 times 3, both positive, gives me 30. So finally, at the end of this, I'm just adding two numbers. So I have negative 25 plus 30. We're adding two numbers with different signs, so we subtract their absolute values. So this is going to become 5, but is it positive or negative? We know 30 minus 25 is 5, but we have to go back to that idea of which absolute value did I have more of. So I have 25 negatives, but I have 30 positives. So I have more positives than negatives. So my numerator is just 5. Okay. So let's see what happens with the denominator. So the denominator is 2 to the third minus 1. So if we go back to the order of operations, we would have PEMDAS, so parentheses, exponents, multiply, divide, addition, and subtraction. So we definitely don't have parentheses here, so we can skip that, but we do have exponents. So I need to take care of 2 to the third. So 2 to the third is just 2 times 2 times 2. So 2 times 2 is 4, times 2 again is 8. So I get 8 minus 1. 8 minus 1 is just regular old subtraction, which is 7. So my denominator becomes 7. That cannot be simplified anymore. If this fraction that we just got up here, where we simplified the numerator, simplified the denominator, if the resulting fraction could be reduced, you need to reduce it. This one can't reduce, so our final answer is 5/7. Okay? And that's it for this video. In the next video, we will look to see how we can incorporate this with a little bit of algebra.